Now that we've seen horizontal stretches and compressions, let's look at vertical stretches and compressions. Now, since this is vertical, we will see a change in the output of the parent function. So here, notice we have our square root function that we've been examining. And notice here, we have a multiple of 2 after the square root. Likewise, a factor of a half after the square root. So the parent function is again f of x equals the square root of x. If we go to graph, we can apply the same guide points as before for the parent function, 0, 0, 1, 1, 4, 2. And so there's f. Now, let's look at g. Since the change is occurring after we apply the square root, we do not have to adjust our x values. Now take the square root and then double. So take the square root of 0 and then double, we get 0. Take the square root of 1 and then double. Take the square root of 4, we get 2, double. So g will look like this, 0, 0, 1, 2, and then 4, 4. Notice that the height of this has been stretched out. We are now twice as far from the x-axis as we once were. Now let's look at h. So with h, again, we can apply the same x values, and then we take half of the output. So the square root of 0, take a half. Square root of 1 is 1, take a half. The square root of 4 is 2, take a half. So 0, 0, 1, 1 half, and then 4, 1. So h is now half the distance that f was from the x-axis. So here we see in g a vertical stretch, and then with h we see a vertical compression. So if we are to write g and h in terms of f, g of x equals, well, we apply the square root function, so we will apply f, and then we double. And then h, we apply our square root function, and then we take half. So notice the 2 occurs after the parent function, and so this multiplication of 2 is going to stretch vertically our function f. Likewise, here our 1 half occurs after our parent function, and it's being multiplied, so our outputs are going to be reduced by a factor of a half, and therefore we see a vertical compression. So if we multiply our parent function by something larger than 1, then we see a vertical stretch. If we multiply by a smaller number, then we see a vertical compression. Now, with any horizontal transformations, they always seem counterintuitive, and that's because we are adjusting the inputs to compensate for what's going into our parent function. So let's take a look at this example. We have how many transformations going on? Well, let's first identify the parent function. The parent is f of x equals the absolute value of x. So the guide points there, of course this makes a v for the absolute value, it's going to look like this. So there is f. So let's take a look at what are the things that are being done to our parent function. We see a subtraction of 4, a multiplication of 2, and a subtraction of 3. So let's first rewrite y in terms of f? Well, what goes into the absolute value? X minus 4. So we can say f of x minus 4. And then after that happens, we multiply by 2, and then we subtract 3. So there are 3 transformations going on. The first one is what's happening to the input, the subtraction of 4. So whenever we subtract 4 from the input, that's going to be a horizontal translation, and it's going to move 4 units to the right. And then we multiply by 2 after the parent function, and so that will yield for us a vertical stretch. By a factor of 2. And then we subtract 3, and that's going to move us down vertically. So 3 units down. So the best way to do this is to look at your guide points and move each one of those. So if we take, let's start with this 0, 0 point. Let's move it 4 units to the right, and then vertically stretch it by a factor of 2. That means it's going to be 2 times the distance from the axis. But it's a distance of 0. So if I double that, I still end up on the axis. Then we move 3 units down. So we will be at we'll be at 4, negative 3. Now let's move the other points. So if we move the point negative 1, 1 to the right 4 units, and then we stretch it by a factor of 2. So we were 1 unit away from the axis. Now we're going to double that. So we'll be at 2 units above the axis. And now we're going to move 3 units down. So we'll be at 3, negative 1. Now move 1, 1, and we will end up at 5, negative 1. And so here we go. Here is our new transformed functions graph. So there is y.